This is Note-Taking Guide 3.3, Matrix Multiplication for Mathematical Decision Making for Life. So we're going to learn how to multiply matrices today. If you remember when we did addition and subtraction, the matrices had to be the exact same dimensions. Well, that's not the case with multiplication. So multiplication is a little bit tricky. So what we're going to do is we're going to look at the matrix. Say matrix A is a 3 by 4 matrix. And matrix B is a 4 by 1 matrix, and we want to multiply A times B. Well, what we first need to do is we need to write down the dimensions. Matrix A is a 3 by 4. Matrix B is a 4 by 1. These two middle numbers right here tell me, yes, I can multiply the matrices. So if these two middle numbers are the same number, I can multiply the two matrices together. If they're not the same number, I cannot multiply those two matrices together. These two back numbers tell me the size of my matrix. So the answer of my matrix is going to be a 3 by 1, which means it would have 3 rows and 1 column. So again, in order to multiply matrices together, we're going to have to write out their dimensions and check those middle numbers. Those middle numbers have to be the same in order to multiply the matrices. So in general, the size of a matrix A would be an m by n. Size of matrix B is an n by p. Those middle numbers have to match up in order to multiply the matrix, and then they would be the size of the outside two numbers. So, can I multiply these two matrices together? So the question is, can I multiply A times B? Well, A is a 2 by 2 matrix because it has 2 rows and 2 columns. B is a 3 by 2 matrix because it has 3 rows and 2 columns. So if I do A times B, then I would have a 2 by 2 and a 3 by 2. So my answer on that would be no, I cannot multiply them together because these two middle numbers right here are not the same. But what about if I do a B times A? B is a 3 by 2. A is a 2 by 2, and now the middle numbers are the same, so I can multiply them together. My answer would be the size of a 3 by 2 matrix. So order does matter in multiplication, which is odd because in all other things that we've learned in math so far, up to this point, multiplication could be done in any order. But multiplication in matrices cannot be done in any order. Order does matter. We have to do it in the order that they write it down for us. So this asks us to multiply B times A. Those bells are kind of annoying today. So let's multiply B times A. So this is kind of a stack method. I don't necessarily use the stack method, but this worksheet's written in a stack method, so we're going to just kind of use it that way. But matrix B is a 3 by 2. It's 3 rows, 2 columns. Matrix A is a 2 by 2. So this tells me, yes, I can multiply them together. And this tells me the size of my answer. The size of my answer is going to be a 3 by 2. So I know that when I'm multiplying this is going to be a 3 by 2. I'm going to have 1 row, 2 rows, 3 rows, and then I'll have 2 columns. I always write out my rows and my columns like that because it's really important to see where my answer comes from. You can see right here now that this answer comes from row 1 and column 1. So I'm going to look at row 1 and column 1, and I'm going to multiply those together. So I even like to come over to the side over here and go row 1, column 1, and then do the multiplying. You do the first number times the first number. So we'd have the 0 times the negative 1. It comes from here and here. I'm going to add that to the second one, so 9 times 5. I'm going to do that math on my calculator, and it's going to tell me the first number is going to be 45. So the first number in my matrix is the number 45. Okay? Now I'm going to erase a little bit of this scribbling that I did and circling that I did over here because I'm not going to do those two sets of numbers again, because to get this answer over here, I would use row 2 and column 1. So I'm going to use I'm sorry, I said row 2, but I meant row 1. Because see right here, I'm at row 1 and column 2 to get into that position. So I'm going to use row 1, column 2. So row 1, column 2. And I'm going to come over and I'm at row 1, column 2, and I'm just going to do my numbers. So it will be 0 times negative 1 plus 9 times negative 3. This is 0, and so 9 times negative 3 is a negative 27, so that number is going to be a negative 27. Okay, I'm not using those two anymore because I'm going to the next one. This position right here comes from row 2, column 1, row 2, column 1. So I'm going to have to use row 2 and column 1 to find my next answer. So row 2, column 1. Row 2 is 8, and then in the column it would be a negative 1, and then plus a negative 6 times 2. So that would be a negative 8 and a negative 12 for a negative 20 altogether for that position in my matrix. Again, I'm done with those. So this time to get this number over here, it's going to be row 2, column 2. So row 2, column 2, I'm going to multiply those two together. So it'll be 8 times 5. And then I'm going to add that to negative 6 times negative 3. So that's 58, I believe, is the number that's going to be on row 2, column 2. Okay. Then we're going to go and we're going to do the next one. So row 3 times column 1. So we're going row 3 times column 1. I'm going to erase these ones. Row 3, column 1. 4 times negative 1 plus 7 times 5. So a negative 4 and a negative 35 is a 31 for my number right there. Right? Did I do that right? 4 times negative 1 is a negative 4. And then 7 times... Oh, I wrote down 5, but it should have been 7 times 2. I'm like, something doesn't seem right on that. It's the 7 and the 2. I don't know where I got 5 from. So that's not actually going to be 31. Sorry about that, you guys. Sometimes I just look at the wrong stuff. That's going to be 10 because that negative 4 and a positive 14 is going to be the number 10. Then the last position comes from row 3, column 2. So row 3, column 2 is going to be 4 times 5 plus 7 times negative 3. So 20 plus a negative 21, which is going to be negative 1 for my answer. You guys, once you get good at this, it doesn't take a lot of work to do that. You just got to practice a few times and you're going to be able to skip a lot of these steps. So this one says find B times A. Again, you guys, it's directional. It matters. So I have to write B first. I'd have 5 and 4, 1 and negative 8. And then I would have to times that by 11, 6, negative 3, and negative 7. This is a 2 by 2 times a 2 by 2. These two numbers tell me, yes, I can multiply it. These two numbers tell me the size of my answer. The size of my answer is going to be a 2 by 2. I'll have row 1, row 2, column 1, column 2. And I have to multiply those together in order to get the values. I'm multiplying rows times columns in order to do that. So the first position right here comes from row 1 and column 1. So row 1 and column 1, when I do this, I'm going to have negative 5. Sorry, let me change to a marker. Negative 5 times 11 plus 4 times negative 3. Because again, I did row 1 times column 1. And then I'm just going to punch those numbers in my calculator. And when I do that, I get negative 43 for that first number right there. Okay, now I'm gonna do the next position, and the next position comes from row 1, column 2. So row 1, column 2. And I'm just going to do that. So negative 5 times 6 plus 4 times 7. So that's a negative 30 and a positive 28. So a negative 2 for my number in that position.